Hi everyone, in this video we're talking about different methods for rationalizing. So you'll notice I have examples from lesson 1.2 and lesson 1.4. That's because there are several different ways to rationalize depending upon what's going on in your expression. So from example 2, we learned how to just rationalize when it's single terms. Okay, so I'm going to start out with part A. My fast little trick for rationalizing is to simply just copy the square root to the numerator. So you have 2 times the square root of 3. And then in the denominator, you remove the square root symbol. Okay, so that is the rationalized version of this. What's actually happening is that we're multiplying by a fraction that's equal to 1. So I am figuring out what I can multiply the square root of 3 by so that I can remove that square root symbol. And because I multiply by it on the denominator, I have to multiply by it in the numerator. So this is how the rationalizing works. In part B, it's no longer a square root. So I actually really like writing this as a fractional exponent because it helps me to see what I should multiply by. So this is x to the 2/3. So when I multiply by another fraction, I'm going to look for something that when added to 2/3 equals 1. So it's 2/3 plus what equals 1. Because that's my goal. My goal is to get rid of that fraction and turn it into a whole number. Okay, and 2/3 plus 1/3 is 1. So I'm going to multiply by x to the 1/3. So this is 1 times x to the 1/3 is x to the 1/3. And this just becomes a plain x. Now, the last thing that I should do is because they didn't say to use the exponents like that, I should turn it back into a root, especially because we were just asked to rationalize. Rationalizing implies that there is a root in your final answer somewhere. So I'm going to just turn this back into a cube root. This is the cube root of x, and that is my final answer. Now for part C, I'm going to do the exact same thing. The 7th root of 1 is just 1. And this is a to the 2/7 power. So again, I need to figure out what I can multiply by that will make this exponent add to 1. So I need to find that fraction. So this would be 2/7 plus 5/7 is going to equal 1. So I'll just multiply the numerators. 1 times that is just a to the 5/7. And in the denominator, this just adds to 1, so it's a to the 1st power. Now again, we should put this back into a root form because they gave us a root in our original question and they didn't ask us to use exponents. So this is the 7th root of a to the 5th all over a. And that's my result for that. So that's how you would rationalize if there's only one expression in each numerator or denominator. Now the question is, if I'm adding or subtracting in the numerator or denominator, how would I change this? How could I rationalize differently? So we do that in lesson 1.4. In example 9, we learn how to rationalize a denominator. And in order to do that, you multiply by what they call the conjugate radical. And essentially, all you are doing is creating a difference of 2 squares. So you take whatever the expression is, and you change the sign right in between. So if this is 1 plus the square root of 2, I have to multiply by 1 minus the square root of 2. Okay? And we do that because when we actually multiply that out, these square roots will cancel each other out. And I will just be left with whole numbers there. So in my numerator, I would multiply straight across, and I get 1 minus the square root of 2. In my denominator, when I multiply these together, I get 1 times 1 is 1. If I multiply 1 times negative square root 2 and 1 times positive square root 2, it's actually going to cancel itself out. And that's the special pattern for a difference of 2 squares. And the last step is positive square root 2 times negative square root 2 is negative 2. Okay, and 1 minus 2 is negative 1. So it's 1 minus the square root of 2 over negative 1. And that can actually be simplified as well. And it turns into the square root of 2 minus 1. And that is my final answer. What I did is I just took this negative 1 and I just switched all the signs up here. Because when you divide by negative 1, it's just going to switch your signs and it's not going to affect the numbers really. Now in example 10, we're going to do the same thing, except I'm going to remove the square root from the numerator. Now, we don't use that one as often. Sometimes it's important to know how to do that. Sometimes it's not. But we're just going to review it as well with our example 9. Oops, that's supposed to be minus. So this was my expression. I'm going to multiply by its conjugate radical. So I copy this expression and change the sign in between. And it doesn't matter if you're changing the sign on the radical like we did here, or you're changing the sign on the whole number. What's important is that you're changing the sign. Oops, that should be over itself. So now I'll multiply it out. Remember, what's going to happen with our root is that the root is going to disappear, and I'm left with just 4 plus h. I'm going to write a minus sign for those signs. And then I'm going to square this last term to get 4. In the denominator, I keep it h times the square root of 4 plus h plus 2. Now, I would not suggest multiplying that in because a lot of times these things can reduce more. So I'm going to leave it. I can always multiply it later. Here I have 4 minus 4 is 0. So these 4's will cancel each other out. And guess what? H over h is just 1. So that's going to reduce as well. So my numerator is a 1, and in my denominator, I'm just left with this because the h is canceled and the 4 is canceled. So this is the square root of 4 plus h plus 2. And that's my final answer. So make sure you ask me if you have any questions about anything in this video, and let me know about how it went.